Good morning, good afternoon, good evening, wherever in the world you are. Welcome to today's webinar, Supercharge your PostgreSQL on Kubernetes, how to send database performance soaring with surprisingly cost-effective cloud services. Today, we've brought together a team of database and cloud experts who will share their insights on how you can optimize your PostgreSQL on Kubernetes with the right choice in a cloud service provider. I'm Janet LaFleur, Director of Product Marketing at Lightbits, and I'm happy to be here today with Stefan Maya, the Chief Technology Officer from Excellent Technologies. Stefan led the team who built MetalStack Cloud, the Kubernetes as a service bare metal cloud that stores your data securely in the EU. Joining Stefan from Excellent Technologies is Managing Director Marcus Finstera. Together, Marcus and Stefan help clients build their cloud-native futures by designing cloud solutions with an agile mindset. And as strong believers in open source, they help by giving back to that community as well. They're joined by Rob Blumendahl, the Principal Solution Consultant at Lightbits. Rob is an expert at architecting database in the cloud solutions with more scalability, better data protection, and more overall efficiency, both operationally and cost-wise. We've got a tight agenda for you today. We'll start with a few roundtable questions to introduce you to our experts. Then we'll hand the mic over to Stefan and Marcus, who will give us a deep dive on the challenges and solutions for running PostgreSQL on Kubernetes. They'll include data from benchmarking work that compares AWS, Azure, Stackit, all against their MetalStack cloud. Then Rob will give you an overview of the Lightbits storage that's an integral part of the MetalStack platform, and we'll finish with a Q&A session. So if you have a question, simply type it into the question chat on the sidebar, and we'll do our best to answer them all at the end. So let's get started with our roundtable. What makes running databases in the cloud so challenging? So, Stefan, what challenges do you find your customers are facing when they're running databases in the cloud?
Yeah, with the rise of microservices, the number of databases explode basically, and it's hard to manage this exploding amount of databases. And on the cloud, the performance is a key aspect. And if you once hit the limits of IOPS or throughput on the storage you get provided by the cloud provider, you get real trouble, and eventually you get a phone call by night, here our database is not running anymore because it does not get enough performance from the storage. What can you do? And most of the cloud providers will limit your IOPS for a while once you hit the upper limit, and you will get in real trouble because your application will get stuck, and your ops people have a big hassle with that.
Yeah, they get that call or that pager notice.
Yeah, exactly.
Yeah.
And there's no way to circumvent these hard limits on most of the cloud providers. Once you hit the upper limit, then you can just wait for an hour or so, and then your database will be able to proceed with the load from the application.
Yeah, that's not good. So Stefan, what challenges do you find your customers are facing when they're specifically running on Kubernetes?
Yeah, specifically on Kubernetes, it's totally different to run databases on Kubernetes than on a traditional VM or bare metal-based deployment, because usually you must use some sort of help from operators. This is a key implementation detail in Kubernetes, which deploys your databases and manage backup and restore and replication to other sites, for example. And this requires more detailed knowledge of Kubernetes and databases.
Okay. Rob, how does storage factor into all this?
It's interesting, right? If you hear Max and Stefan stating that the scale of the databases is so fastly growing, what we're seeing is that with the scale, you also want to do autonomous snapshots and as much snapshots at the same point in time. And the clouds making snapshots is already one challenge, but doing hundreds at the same time, that's the next challenge. And yet, as Stefan correctly said, you have an explosion of number of databases because you scale that wide. You have to allow yourself and enable yourself to be that smart, to create those snapshots and to capture the snapshots as a backup feature for the first instance, right? So you don't want to limit yourself by going into the cloud and then not just hitting the performance deck, but also hitting the functionality deck that you can't do enough snapshots at the same time to acquire a lot of database at the same time. So that's another gotcha you have. And the other thing is that Mark's correctly stated, I love to challenge all the cloud providers to do a multi-zone replication on storage. Or when you spawn on a different rack in the same zone, let's find your storage again. Right? No, so that's the key things. And the other key thing is that when you do make your snapshot, is it instantly available? Or you have to wait a couple of hours before the first couple of 100 gigabytes are effectively stored on an S3 bucket. So these are the challenges, right? It's not just getting into the cloud, but it's also all about being able to manage your storage and what you want to do with it as like you are on-prem.
Yeah, I can see that. So this one's for Marcus then. So Marcus, are all cloud providers more or less the same? Aren't they all the same?
In certain degrees, they offer similar services, but there is differentiation in the service quality, in the performance, and also in price. And that's also a topic of today to compare those cloud providers and see what the one does good and the other perhaps has to rework some stuff.
Okay, well, that is the last of our roundtable questions. So let's get on to the main event here. How fast can PostgreSQL run, and how does MetalStack stack up against the big cloud providers? So take it away, Stefan and Marcus.
Yeah, sure. So
that's your part, Stefan.
Exactly. So why PostgreSQL and run it on Kubernetes? As I said before, the rise of microservices requires a lot more database instances as we are used to have in the past. And PostgreSQL is one of the stars in the RDBMS world today because it's open source, very stable and very competitive in terms of features compared to well-known competitors like Oracle, for example, or DB2. So we see a lot of movement away from proprietary database systems, moving to Postgres as a database system, because otherwise licensee costs will explode if you have hundreds of databases to serve all your microservice requirements. And Kubernetes, on the other side, is actually a de facto standard for application deployments. So most probably, if you have microservices, they will be deployed in Kubernetes. And to run them side by side alongside with the database makes them fast and makes them automatically managed. And this should also be the case for the database. So all the requirements regarding backup and disaster recovery should be managed by operators specific for the Postgres database, and move a lot of, or make a lot of work not required anymore for the operators, so the persons in charge. Yeah, and that's why we think Postgres is a perfect fit for microservices on Kubernetes.
Okay, so here's the fun part. Who's the fastest? Which cloud is going to run this Kubernetes, PostgreSQL on Kubernetes the fastest?
Yeah, now let's dive into the comparison. And if you want to do performance benchmarks amongst cloud providers, you have lots of degrees of freedom you can choose. And yeah, you need to have some constraints to get all of these degrees somehow compressed. And yeah, it's many providers. You have many server types that are different, and they all have their storage tiers that come into play. So we decided to look at only a set of cloud providers, and you see the logos here. So we have two hyperscalers, AWS and Microsoft Azure. And besides that, we have smaller cloud service providers that are available in Germany, the Metal Stack Cloud, and StackIt from the Lidl Schwarz Gruppe. And yeah, we compared those against each other and said, yeah, we want to have same hardware sizing, so the machine types need to be comparable. And we use a storage tier at a fixed price point. And this is €0.50 per gigabyte month. And we just ordered the best storage tier that we got for this price. Yeah, and these are the ingredients for our benchmarks, doing PG bench runs on those systems. And yeah, we will take a look later on. But to the set of providers, I wanted to say, Janet, perhaps we can go back. We would have tested a lot more providers, but it was not that successful because of manifold reasons. So we had, for example, Exascale, which was on our list. And as we did the tests, it appeared that they do not have persistent storage from a central place. I guess in the last week they offer this now, but when we did the test, it was not available. So we did not test there. And also OVH from France was one of the providers we thought about, but they had a policy that you can only get bigger server types if you put some more credits into the system, and yeah, it did not fit our case here. And with Google, we had some troubles. So if you want to order multiple CPU cores, you need to increase your quota. And this is normally done with a robot, but if you want to have larger machines, you also have to do a phone call with the sales support. And we did all of this, but in the end, we just saw that the most performant storage tier is not available for the server type and location we had in mind. So there is a very big compatibility matrix where you get which storage tier in Google. And so this was the reason that Google was not part of this benchmarks. Perhaps in the future we will do a second round, Janet. Let's see. And so this was the general setup. And now we can dive into the details there. So we used managed Kubernetes from each of these providers. And so the control plane is hidden, and we just have node pools, worker pools, where we said we want to have 48 virtual CPUs for each and 128 gigabytes of RAM. And we measure the performance between 2 worker nodes. So we installed a Postgres operator to the Kubernetes cluster, and this operator should instantiate 2 Postgres instances, one on the one worker node and the other one on the other. And then we measured from one to the other the PE bench. And this for read-only transactions and for read-write transactions. And what is also worth mentioning here is our setup of these custom resources, which were deployed to the Kubernetes cluster to get these Postgres instances. You see that we use 24 virtual CPUs and 16 gigabytes of RAM. So we said, don't use the whole CPU you have available, because it might interfere with the benchmarks. What else might run on the servers? We said, we take half of the cores for the Postgres processes. And each of the runs had 50 gigabytes of persistent storage that is delivered from a central place of the provider. The advantage of this setup is that you can also factor in the network communication. So if you do test just on one node, it's not that expressive. And if you measure from one node to the other, you have network as a factor. And you see here a small pointer. What is the installation guide we followed for Postgres and the operator. Okay, and now it gets interesting.
Yeah.
We come to the results.
Okay, I kind of gave them a preview, but here's the results for read performance.
So I have to mention that we had support from Postgres experts for those benchmarks, because we are all in the cloud native world, and Kubernetes is familiar to us and bare metal things, but Postgres is a very big topic, and we had support of our partner Cybertech at this point, which ran the tests and validated the results. Here you see the read-only performance of the different providers. And we did 6 runs and averaged the number of transactions we got. And we see AWS performs not that well. It has not yet 10K transactions per second. And then we have StackIt, this European cloud, which has around 30K transactions per second, which is okay. Then we have Azure, where we see 40K transactions per second, and MetalStack Cloud has double the amount of transactions compared to Azure. This is a nice picture for us, because we built this cloud and see that we performed well. That's the read-only part. But more interesting is a read-write. This is mostly used in your transactions and in your applications. And there, the big picture is comparable. So we also have AWS at the end of the tail. Then we have StackIt on place 3. But the difference between MetalStack Cloud and Azure is is not that high as in the read-only case. So we are 50% better there, but Azure does a quite nice job. And we would guess from our standpoint that Google would be around Azure's performance, but yeah, we don't have the evidence yet here. Okay, and yeah.
Next slide.
Yeah, would be nice. So this is a summary what we just saw, and from the hyperscalers, Azure showed the highest performance, AWS the lowest in both cases, and yeah, it was also nice to see how you can configure your storage needs in the different clouds. And the hyperscalers have a very handy concept there. So there you can specifically define your storage needs in terms of IOPS, throughput, and so on, and deploy custom storage classes into your Kubernetes cluster. So you don't have categories you need to climb the ladder up, so you can configure it to your needs. This was a nice outcome. Yeah, and summed up, we can say running heavy load databases on hyperscalers is possible, yeah, and you should choose wisely is our setting there, because yeah, there are differences in the storage classes, and if you pick the standard storage, it's most often the case that it's very costly, and yeah. It would be nice if more users take a look at other storage options they get from those hyperscalers besides the standard tiers, and also other providers, because as we see, they are not performing badly. And there is one additional finding we had in the current media from database architects. They showed that despite flash storage is getting faster and cheaper for end customers, in AWS, it does not get faster over the years. And yeah, that's really the case. IOPS are a valuable good, and they can come costly, can make up a good portion of your cloud spends. And yeah, you should consider other providers and other storage tiers here. And from the pricing perspective, this is also interesting. So what is the price for this fixed hardware set on the one side? We have that on the left-hand side on the slides. And the more interesting thing on the right side, what costs are incurred per IOP, per IO operation. And there we see that yeah, AWS is costly, and yeah, Azure does a very good job, and the Metal Stack Cloud is in this regard as expensive, as cheap as the Azure Cloud.
It's a good comparison.
Yeah, these were the results we had, and now the question is, where does this come from? Why is such a setup faster than other systems? And this is going to be talked about by Stefan.
Yeah, you might wonder why a new small cloud from Germany is able to provide faster storage or database performance than the big cloud providers. And this can be split up in 3 portions. The main reason is that MetalStack Cloud, as the name implies, provides Kubernetes as a service on bare metal machines. So there's no virtualization in place, which is the case normally for all of the cloud providers. So the whole overhead of virtualization, which really hurts for IOPS, for IO especially, not so on the CPU part, but for IO virtualization hurts. So we have bare metal machines in place, and your worker nodes you have in your Kubernetes cluster is a whole physical machine. Next important point is our network. It's very fast. It's quite modern, open compute based 100G technology, which makes it super fast to talk between worker nodes and to talk to the storage, which is the third part of making it fast, the very fast Lightbits storage. It's all flash from the newest technology, from the inventors of NVMe over TCP. And yeah, that's the reason why MetalStack Cloud can compete with modern hyperscalers, even if we are small and new.
And the nice thing is, you can get that performance in a managed service directly from our MetalStack Cloud public offering, or if you decide to build such a system in your data center, this is also something we do. And
for example, if you think about moving away from VMware Tanzu because of the Broadcom acquisition, MetalStack Cloud is, as Marcus said, available as an on-premise solution, which offers you Kubernetes as a service as you expect.
Okay, well, that's a great segue. Thank you, Stefan and Marcus, for sharing those really remarkable numbers, performance numbers. So, Rob, can you give us some more detail about Lightbits and how it's architected?
Yeah, how to add a couple of good lines to that speech, right? It's fantastic to see that having a partner and a customer like MetalStack throwing those numbers against the big hyperscalers is phenomenal. So so what do we add to the game? Can you go to the next slide, please, Janet?
Okay.
So basically what we're trying to do as Lightbits is the golden triangle for us. It's cost efficiency, resiliency, and high performance. Normally, out of those 3, your storage provider is capable of just providing 2 out of 3. Mm-hmm. Either you're cost efficient and you have resiliency, or you're cost efficient and you have high performance, or you're resilient and have high performance, but then you have to pay a lot of money for it. So that's the first game, right? And that's what in the outcome you saw from when Mark's presented. It's that we do the highest IOs and we have the lowest cost available, and and we are resilient because what we can do is see in the bottom right, we have multi-zone replication in the cloud or wherever you want to have us, right? So that's another cool thing. Comes out of the box. The resiliency is there, and there's no money charged for it, right? So it comes with the product. Another cool thing what we can do is that we scale, right? So we start with 3 nodes up to 16 nodes, and you can scale up to 75 million IOs with less than a millisecond latency, and that's killing rock solid performance. That's another key factor we have, and then of course the latest one is the TCO. So we have seen customers where we did some TCO calculations that against some other cloud providers, we reduced more than 80% of TCO by choosing Lightbits with cloning and snapshotting. So there's a lot to gain, there's a lot to win, and there's a lot to achieve. And as the clouds, whether it's public, private, hybrid, or edge cloud, where you need fast performance, low latency, and a good resiliency and cost effective, we should be on the short list. That's where we add value, right? So, you know, and then when you lead to this game, right, where, you know, we of course we compete against that storage area networks and hyper-converged, and all of the pros and all of the cons. And I don't want to go into detail on all of those three. What I would like to go is think about modernization. Think about what Stefan just said on his network. It's open networking, right? So as we're open. You can use any server brand out there. You can use any network as long as network is TCP, right? So standard TCP networking, level 2, level 3, disaggregated storage, we're there. No bottlenecks on CPU versus storage, or the other way around. No bottlenecks on, you know, you're still stuck to fiber channel, and you know, I want to go to the next level, and therefore I have to upgrade my fiber channel, and I just already upgraded my TCP network. Get rid of those. And directed storage, right? It's always the same. I have to put it local, and I can't use 20 to 30%, and the rest is just there, sitting, doing nothing, and costing you a lot of money. So yeah, modernization, NVMe over TCP is your answer. Native end to end, right? Not to the box where you have to convert to another protocol because that's how the storage works. End to end, like your NVMe disks sitting somewhere in the cloud is functioning like it's local. Yeah, next slide, please. Right, so how do we work, right? And then we just mentioned it and already earlier, NVMe over TCP. We are the founders of the NVMe TCP protocol. We have open sourced it so that the whole community, everyone out there can use it. And we're seeing the adoptions now from the largest storage guys. They are picking it on, and they can't leave it behind, right? So we're seeing some from Gartner, which is next slide. So I have to stick that for a minute. It's a nice cliffhanger. But we're extending the NVMe network outside your server into the storage cloud, which is Lightbits. Super fast performance, 160 microseconds latency. We're not talking milliseconds anymore. A very, very consistent latency, and that is a key factor. And we achieve the consistent latency by our global intelligent flash management. The way how we write, the way how we read, the way how we do our ASIC coding, all those secret sources internal in the box gives you the high performance. No weight on reads and writes. No cliffhangers, right? So no write cliffhangers as you might have on SSDs, that it always goes fast and suddenly you hit this huge wall because you need to clear some spaces before you can write. And every time you write on the die or you clear the die, the whole page has to wait. And you know that you can't have that anymore, right? So that's what we're fixing. Oh yeah, and we're completely in user space. No kernel dependencies anymore, which allows you to run on different Linux kernels and which allows us to do online upgrades. So no more downtimes. And you know, the way how we treat it, right? So you know, a little bit internally, but you shoot an IO, this IO gets its own thread, its own queue, and the next IO, whoops, new version, new thread, new queue, and nothing happens. You just keep on performing and just keeping your storage to go. Can we have mixed versions through the cluster? Yes, of course we can, because we do rolling upgrades, but you're fine. Next slide, please. And then there we go, right? So I just linked a little bit to Gartner. Gartner expects that 25% of everything goes to storage will go over NVMe over Fabric. Huge compliment to us as the inventors, right? The industry is grasping it. The industry is saying, hey, NVMe over TCP isn't going away. It's the way forward. It's how to modernize our network. Stick to one network. It's secure. It's safe. It scales. You can do bonding. You can do teaming. And if the network grows for speed, there's nothing you have to do. You don't have to bet on two different network types. One network type, segregate it out, and away you go. And the last comment from IDC, right, allows organizations to provision scalable storage without having to change the network architecture.
Mm-hmm.
That's what it is, right? Gain performance, gain scalability, and have your team focusing on one network. And that's what we do as well in the cloud providers and hyperscalers. Are we available in hyperscalers? Yes, we are. How do we attach? Through NVMe over TCP. And that's the easy route in, right? So yeah, we're making it happen. So the value, right, on all the other things I just said. So what is it we do, and how can we help? So first of all, software defined. So any commodity storage, as long as NVMe SSD, right, on any server type. It's a clustered architecture that heals itself and scales easily. What we mean with healing, if one node fails for whatever reason, through our replication and our failure domains, we will make it happen that volume will be then live on another node without the network interference, right? So we just hop from one node to another, make it live, and you go through. And if the other node doesn't come back in a adjustable time, we can simply turn it off and start replicating and rebuilding all those volumes which were part of that node to other nodes in the network. Again, fully automated, nothing you have to do. As I already said, right, standard networking, standard NICs, no reason to reconfigure. If you got level 2 working, great. Level 3 working, fine. Not a problem at all. We just stick into it. Just plug it in and take it away. Intelligent flash management, as we discussed a little bit before, right? We do thin provisioning, compression, and Kubernetes farms, 2 compression, 3 compression, easy to be done. We're not keen on making the numbers too high because every time customer scenarios are different. But snapshots and thin clones, it's we're copying the metadata, we're not copying the data, so it's a redirect on write, saving space, but also allows you to do hundreds of snapshots and clones at the same time. So even those things are done in flight and on the speed you need to have it. And then the clients, all Linux kernels are NVMe supported out of the box. Microsoft Windows is now working on it, right? So Microsoft is the next Windows version will have NVMe over TCP. And guess what? Who they're testing it against? Yeah, Lightbits as the number 0 one, the first one to test it against. Oh, so does VMware. Right, so if it comes to NVMe TCP and you look at the big vendors, then we are the number 1 to test it upon, to verify it on, and to make sure it is all working fine and goes live. And then for us, it's plug and play. Yeah.
Okay, great. Thanks, Rob. So it's time for questions. We've had quite a few come in, but it's not too late. You just use that little question mark on the sidebar to type in your questions. Let's start with one that was directed at Stefan about how many different instance types or sizes do you offer for your MetalStack cloud?
Actually, we have 3 different T-shirt sizes of our machines, of our physical machines. It's the small, medium, and the large box, ranging from 8 CPU, 32 gigs of RAM to 48 CPUs and 192 gigs of RAM, all connected with 25G dual attached to the network. Yes.
Oh, okay, good. Gives people options. For Rob, what kind of compression rate does Lightbits get with containers, with Kubernetes?
Yeah, as I said, right. So I say 2 to 3, and it depends how it's done. It's if you got 500 Kubernetes Postgres instances, and so the instance, right? That's an easy compute, right? Because you don't have to replicate all the instances, but it's also about the data and the database information in it. So we normally say 2 to 3, and then most likely better, but let's stick to those.
That's a good ballpark figure. Okay.
Yeah.
This has to do with pricing for Stefan. Is your cloud pricing structure set up like AWS with multi-year reserve pricing availability?
Not yet, but who knows what comes? Yeah, if we have a demand on that, so we open for talks.
Okay, this one's for Rob. It's about the thin clones. You mentioned thin clones. How are thin clones different from snapshots?
Right. So snapshots are mountable, but you can't change it. It's read-only. Thin clones, you can attach those to another Kubernetes. So with the Kubernetes, right, so we have our CSI driver, and basically what you can do is clone a complete instance with the data and mount that under a different name in your Kubernetes, and also have then a new volume attached to it. Right, so that's all in there. You have our YAML files. We can even do Kubernetes live migration, so you can move it from one node to another without going offline. So yeah, that's basically where it comes down to, right? The thin clones, as again, right? It's redirect from write. They're writable. They're volumes on its own, and snapshots stick to the original volume, and you can't write them because it's a snapshot.
Oh, okay, cool. Well, this one is related, but it's really more for Marcus and Stefan. Do you have a limit on snapshots that customers can create for a single volume, and are there extra charges?
So no, there's no hard limit. It's as Rob already said, you can create hundreds of snapshots, and we charge consumed volume. So what's written on the snapshot effectively by changes on the origin.
Okay. Here's another one for Stefan and Marcus. What other databases beside PostgreSQL do you support?
So basically, you can deploy in Kubernetes on our managed Kubernetes whatever database you might want to. But for Postgres, we have a partner, as Marcus said, Cybertech, which you can get extended support from us. For all others, we don't offer extra support for other database vendors yet.
Okay, and then the last questions, kind of two related ones for Rob. And I think you kind of touched on this already, but maybe they wanted more information. How does Lightbits handle failure, and can it scale without service disruption?
Oh, that's a very nice question. Did you get another hour? So how do we manage failure? So there are a couple of things, right? So first of all, we have elastic RAID in the box. That means that if a disk fails, we simply rebuild the data. So let's say you have a RAID construction or a erasure coning RAID construction of 7 plus 1, just whatever it is, up to 23 plus 1, right? So let's say you have 7 plus 1, one disk fails, then we convert the 7 plus 1 back to 6 plus 1. All the new writes will just be written as 6 plus 1, but all the other data will be converted back to 6 plus 1. So making sure that we're always safe, we're always protected. Now, if you then add other disks, those new disks added will just become extra capacity, and then the new writes will be 7 plus 1 or 8 plus 1 or 9 plus 1, depends how many disks you've added. And then the already existing data will not be rewritten again because they are already protected, right? Only the new writes will get the new layout. Then, so that's inside the storage array, inside the node. Then on top of the node, you can have a replication factor, whether you do a 2 or a 3, a 1x, 2x, or 3x. 1x, of course, is 1 copy, 2x is 2 copies, and 3x is 3 copies. So if you run 1x and the node is down, hey, there's nothing we can do. 1x is 1x, right? But if you got 2x, then basically we start synchronously replicating the data to another node. And if you got 3x, we copy them to two other nodes. So if the first node fails, then our cluster environment sees the first node has failed, or the primary node has failed for the volume, and then the secondary or third node will come up as the live node for that client. Is a primary node just a primary node? No. A volume has a primary node. So each node on itself, if you go to up to 16 nodes, they can all be a primary node for a volume at any point in time. So it's not just one primary node and then 15 followers. It's complete meshed for that perspective, right? So that's another cool thing why we get the performance as we need to have it. And on top of that, we get failure domains. Very interesting. So if you have 2 or 3 data centers and you will build 3 failure domains, when I create a volume, I can determine where my volume starts from. So if I want to start from the first availability zone and then second and the third, I can simply scale that out and making that happen in that sequence. So that's all the things we have in place to make sure that our customers are safe and keep running.
Great. Well, that's the last of our questions, but I wanted to talk about KubeCon in Paris. Stefan, you're going to be there?
We from Metalstack Cloud will be there on booth 9. M9, yeah, together with our friends from Lightbits, and so please visit us, get more details, get more insights, get more numbers.
Mm-hmm. And there's a discount code if you need to get to register. It's right there on the screen. So thank you to our presenters, Stefan, Marcus, and Rob, and thank you to our audience for asking some cool questions and for staying with us. And look forward to seeing you at KubeCon.
Thank you.
Yeah.
Thank you.
Thanks. Bye.
Bye.